Hi guys. Today we're going to continue with our fraction problems with radicals. Just to recap, these are the questions that you should ask yourself and the order that you should ask them in as you're trying to solve or simplify one of these problems. Just as a reminder, your ultimate goal in these problems is not just to simplify, but to make sure that you don't have a square root symbol on the bottom of your fraction. To do that, first, we should check and see if there are any perfect squares that we can take the square root of right now. Then, we should check and see if our fraction itself can simplify. Do you have a fraction that says 8 over 2? That can simplify. Then, we should do a factor tree and check and see if we can get our pairs of numbers, right? If we can get a pair of numbers, they can escape out of the radical. So we're going to do a factor tree and we're going to look for pairs. Now, all of these things should have worked on last night's homework. The new thing for tonight's homework is maybe these things don't work. Maybe you've done all three of these steps and you still have a radical on the bottom of the fraction. Then we're going to do something that's called rationalizing the denominator. And that's what today's video is going to be about. It's going to be about how do I rationalize the denominator? How do I get that square root out of there? Okay, so let's do a couple examples. Here is my first example. Now, again, I see I've got that square root below the fraction bar. It's the square root of 2. So my ultimate goal is to make that square root symbol. Like the 2 can still be there, but I don't want that square root symbol to be there. Now, we can't just square it and say like, ooh, yeah, it's gone now. You're not allowed to do that. So let's go through our list. Step number 1. Do I have any perfect squares? No, 7 and 2 are both prime. They're definitely not a perfect square. Step number 2, can I simplify my fraction? Well, I mean, I could, but it's going to turn into a decimal. And we are not using decimals at all, ever in this chapter. If you're writing me a decimal, you're doing it wrong. So, no, I can't simplify this. 7 is not divisible by 2. Step number 3, factor tree. See if you can find some pairs. But 7 and 2 are prime, so I can't factor tree that either. So I'm lost. I've got nothing, right? No, I can't get anything away. So this is where we're going to rationalize our denominator. So my ultimate goal again is to make the 2 on the bottom not be underneath the square root symbol. Now, the only way for that 2 on the bottom to get out of the square root symbol is if I have a pair of 2's. That 2, it needs another 2. So let's give him 1. Let's put another square root of 2 on the bottom. Now, whatever you do to the bottom, you have to do to the top as well. So if I'm going to give the bottom another square root of 2 so that I have 2 square roots of 2's, I have a pair, then I have to do that to the top as well. Whatever you multiply the bottom of a fraction by, you have to multiply on the top as well. Yesterday in our live session, we learned that when you multiply 2 radicals, you can just put them together under the same radical. So on top, I now have the square root of 7 and 2. And then on the bottom, I have the square root of a pair of 2's, that was my whole goal, right? I wanted that pair of 2's on the bottom so that I can circle them. One of them goes out. It's not under the radical anymore, but it is still under the fraction bar. So make sure that it doesn't like magically float to the top. The other one is poof, gone. And since I now have no more numbers underneath my radical, I now have successfully gotten rid of the radical under the fraction bar. Now on top, I did not have a pair of numbers, so I'm just going to multiply the 7 and 2 back together. Just a little side note, you cannot simplify this fraction because the 14 is under a radical and the 2 is not. So you can't simplify numbers that are inside and outside. If we had two numbers that were both on the outside, we could simplify those. Or yesterday we learned that you can simplify numbers that are both on the inside, but not one inside, one outside. So the square root of 14 divided by 2 is my final answer. Let's try one more together just to make sure we got this. Okay, square root of 7 over the square root of 12. Okay, well, let's run through our other steps because it is possible that other stuff will work on this. So I don't want to jump straight to just multiplying by 12 on top and bottom. So first step, are there any perfect squares? No, I don't know the square root of 7's prime, but I don't know the square root of 12, so no perfect squares. Step number 2, can I simplify my fraction? No, there's not any numbers that divide evenly into 7 and 12, so can't simplify. I can try though, right? Because they're both underneath the square root, but it doesn't work. Step number 3, factor tree. See if you have a pair of numbers. Now I can do that on this one. So 7 is prime. I can't factor tree the 7, but I can factor tree the 12. 12 turns into 2 times 2 times 3. And look, I do have a pair of numbers. Right? I've got a number right now already who can escape out of the radical. So I have my pair of 2's. One of the 2's is going to escape out here, and it stays under the fraction bar, but not under the radical. Right? This 2 is poof, gone. So now it says the square root of 7 divided by 2 times the square root of 3. Well, I've exhausted all my other options, right? No perfect squares, nothing simplified. I found a pair of 2's, but I still have a square root of 3 on the bottom. So now I'm going to rationalize. Now, the only thing that I need to get out of the radical that's on the bottom of the fraction is the 3. So all I need to put in this problem is one more number 3. So the 2 has already gotten out of the radical. We don't need to worry about the 2 anymore. We just need to worry about the 3. So I'm going to multiply the top and bottom by the square root of 3, giving me a pair of 3's. So this pair of 3's, one of them comes out here, and it will multiply with the 2 that was already out there. This one is gone. On top, 7 times 3 is 21. And so my final answer for this problem is the square root of 21 divided by 6, regular number 6. All right. Well, let's see if you guys can try a couple of these without me. Make sure that you ask yourself those 4 questions as you're going through the problem. And then pause the video, and when you're ready, we can check your answers. All right, I hope you did the problems. So let's check our answers. For number 1, I got 2 times the square root of 70, and then divided by a regular number 15. That first one was a little bit intense. So here's my work. So I started by splitting it into 2 separate radicals because I decided that I could not simplify 56 and 45. They did not have anything in common. Then I factor treed my 56 and I factor treed my 45. So you can see that on this step right here, 56 turns into 2227, and then 45 turns into 335. For my 56, I had one pair of 2's. That would be this 2 out here. And then for my 45, I had one pair of 3's. That would be this 3 out here. Now, at this point in time, I still had a square root on the bottom. So that's when I decided to multiply by the orange square root of 5. So I multiplied the top and bottom by the orange square root of 5. That gave me a pair of 5's right here, which became just a regular outside 5 on this step. This pair of 5's became this regular 5. As a final step, I multiplied my numbers back together, right? So all my inside numbers got multiplied, and then my 2 numbers on the bottom got multiplied, and 2 were at 70 over 15. So that's how you do number 1. All right, let's check number 2. And number 2 is a little bit tricky. There was a longer way to do the problem, and then there was a shorter way to do the problem. So I'm going to show you the shorter way. The shorter way to do the problem would be to recognize that 9 over 18 can simplify. 9 over 18 will simplify to 1/2. Now, this is not the only way to do this problem. This is just the quickest way to do the problem. So if you did the problem a different way, but you got the same answer, then what you did was good. After I simplified my 9 over 18 to 1/2, then I split it up. I said I don't know the square root of 2, so I'm going to give him a buddy. I'm going to give him a partner. So I have a pair of 2's down here. My pair of 2's on the bottom turned into just a regular 2. And then on the top, 2 times 1 stays a square root of 2. So this again is the fastest way to do question 2, but not the only way. This concludes today's video on how to rationalize denominators.